Okay, welcome back to the last installment of SPSS 5, Simple and Multiple Regression. Here we'll take a look at the multiple regression example from Chapter 14 of Yaki. So I next want to switch over to our data file. So you'll find that on Blackboard. It's called Meaning in Life, and we have three predictor variables in this data set: connectedness, optimism, and success, and we're trying to use those three predictor variables to predict meaning in life, some measure of how well we have meaning in our lives. And so I want to run the analysis, so I'll go to Analyze and Regression and select Linear. And what I'll need to do, and I've already done it here, is I'll put meaning as the dependent variable, and then I've entered connectedness, optimism, and success as the independent variables. I'll also, under statistics, want to select estimates, model fit, and descriptive statistics, and go ahead and click continue, and then click OK. And when I do that, I get our output. You can see our descriptive statistics are first, so I've got means for each one of our four variables. The dependent variable is 47.2, and it gives us our standard deviation. So those are things we'll want to report in our write-up of this. We also see that there were 30 participants in the study. Under correlations, we can see the Pearson-R correlations between the four variables involved here. And so if we look at this first column, that is our dependent variable, and looking down, so we can see that the dependent variable has a Pearson-R correlation of 0.56 with connectedness, and 0.66 with optimism, and 0.555 with academic success. We can also see the correlations between the three independent variables in this triangle right here. So between connectedness and optimism is 0.307. The Pearson-R between connectedness and success is 0.425. And finally, between optimism and success is 0.47. Down here we can see that all of these are significant at p equals, or alpha equals 0.05 on a one-tailed test. So by default it gives you a one-tailed test. And then finally our ends there, so we can see that it was a fully filled model. We had the same numbers in each one. So moving down, we can see that under model summary, this answers our question: is what is the relationship between the variables, predictor variables, and our outcome or dependent variable. Our R squared is what we're interested in. This multiple R squared indicates that all three of those predictors will predict about 0.606 of the variance in our dependent variable, or about 60.6%. So our model is pretty robust and strong, so a lot of the variance in our dependent variable we can predict from our model containing these three predictors. Now this doesn't tell me here whether that's a significant value, in other words, is R squared equal to 0 or not. However, down here it does. So our null hypothesis, you recall, was R squared is equal to 0. However, this is very highly significant. Our P is less than 0.001, so that tells us that our R squared is indeed different from 0. So our overall model is significant. Down into the coefficients table, we can see for each one of the predictor variables, as well as the intercept, which is called the constant here, as you recall. So here's our unstandardized coefficients. So these are our lowercase b's in our formula for the equation. And so we can see 0.691, 0.653, 0.599. This tells us for one unit increase in connectedness, I get a 0.691 increase in our dependent variable, which was meaning in life. So connectedness is related to it, and notice that that number is positive. So the higher your level of connectedness, the greater the level of meaning in life that you have. So again, our unstandardized regression coefficients tell us for a 1 unit increase in the independent variable, how much increase would we expect to see in the dependent variable, keeping all the other independent variables constant. The other thing of interest in the coefficients table is our beta coefficients, and remember these are standardized, and these are actually what are subjected to the statistical test. We can see that we have a t-value for each one of those, and then the level of significance. So recall that we had 3 research questions around each of the individual independent variables, and so here is the test to see if connectedness is significant. We see it is because it's 0.021 for the p-value. Optimism is 0.003, so that one's significant. However, under success, we see that it's not significant because it's greater than 0.05. So that's a kind of an interesting outcome, and part of the reason for that is because success is a highly correlated with both connectedness and optimism, and so this might be a little bit of a surprise, but this is kind of how multiple regression works, is that you might think there's a simple relationship between 2 variables, but actually it's confounded by multiple variables that all sort of explain the same thing. So this tells us that connectedness is significantly related to meaning in life, optimism also. However, success by itself is not taking into account those other variables. So let's go back to the SPS or the PowerPoint presentation and go back and see how we'd interpret these results. So we have our 4 hypotheses that I put out there at the beginning. Is connectedness related or predictive of meaning in life? Is optimism predictive of meaning in life and success, academic success? And then this one, recall, is about our overall model. So in evaluating this, we can see that our beta value for connectedness is that it's equal to 0.336 with a p of 0.021 from our coefficients table. Optimism, we also get a significant result, but we did not get a significant result for academic success. And then in terms of the overall model, all 3 variables being able to predict meaning in life, our R-squared value tells us that yes, indeed, this model with these 3 predictors is able to significantly predict meaning in life at a level that's less than 0.001. And that came from our ANOVA table. So taking a look at how we might actually use and develop and use the regression equation. So using the data from the coefficients table, I can go back and I can complete this regression equation. So we had, again, the intercept, and then here's the coefficient for our first variable, coefficient for our second, coefficient for our third. And so what I did then is I went in and put in for connectedness and optimism and academic success, put in those variables, and so actually putting the numbers in there from the table, we can see what that equation would look like. All right, so now if I knew some values for a particular person, so if I knew connectedness was equal to 25 on a scale and optimism was 14 and academic success was 12, then I could actually figure out what I would expect the overall meaning in life score to be. So I simply take those numbers and put them in the appropriate place in the equation and crunch the numbers with a calculator and come out with a value for a meaning in life of 31.63. That would be our estimate for what we would have based on individuals that had the scores on connectedness, optimism, and success shown here. All right, so in terms of the write-up, the APA write-up, Yaki provides this. It says a multiple regression was conducted predicting meaning in life from the variables connectedness, optimism, and academic success. And then he goes on to say that overall the regression was significant. Then he provides the F value that was reported in the ANOVA table, and then P values, and then R squared. And I recognize the fact that I did not format this properly, and I apologize for that. But then he goes on to say of the predictors investigated, both connectedness and provides the beta for that and the T value as well as the P value, and optimism were significant. So he provides those statistics in there, and then goes on to say academic success was not a significant predictor of meaning in life. Again, provides the beta and the T t-score, and then the p-value. So that gives you an overall look at how you would write that up. Again, very formulaic. If you do it on a different set of independent variables, you can just take them and drop them in there and put the appropriate numbers in there and the properly formatted abbreviations, etc., in there. And so that ends up the discussion of simple and multiple regression. Good luck on your assignment, and good luck in the course.